Hi, I'm Monica Ivantysynova. I'm a professor at Purdue University, the Department of Agricultural and Biological Engineering, and I have also an appointment in mechanical engineering. I'm also the director of the Maha Fluid Power Research Center, one of the largest fluid power research center in the United States at any university at the moment. And we'll talk a little what I'm doing in research here. Let's go and show you some inventions we made in different areas. So here this poster shows an invention we made just 1.5 years ago, where we used the models we developed for understanding the physical behavior on pumps and motors to investigate some new ideas. The belief of current research or current designers of pumps and motors, and for many years, maybe decades of years, 60, 70 years back even, was that the surfaces of parts of the pump need to be very smooth and ideally flat so that they can seal against each other and run very smoothly. Now, by investigating some problems, we had an idea. Let's introduce a sine wave to one of those surfaces and see if that helps or makes things worse. And unexpectedly, it made things not just a little better, it improved the behavior of that interface between, we call this cylinder block and valve blade, so much that it was nearly unbelievable. We were able, with that sine wave, plus minus 1 micron introduced on that surface, to reduce power losses generated in that part by 60%. 60%. Okay, this was simulation. But we went ahead and manufactured such a part and took measurements. And the measurements showed us that we could improve the efficiency by this one change in design by 10%. Amazing result. Okay, I want to show you one more. So what you see here is the displacement controlled excavator. I was talking prior when I introduced the research areas I have here in my lab. So normally this machine, as you can see it operating everywhere outside, would have a big valve block and a single pump powering all those actuators. We took the valve block out and put individual pumps for each actuator in the machine. And now this machine, I'm repeating, is saving 40% of fuel during operation. And skilled operators, Caterpillar provided them, and they tested this machine, could improve the efficiency by 70%. So this machine made in this lab here has a higher productivity, can remove more fuel, more soil during operation, and save 40% fuel simultaneously. Okay, so what we see here is a test rig, a hydrostatic dynamometer, where we test transmissions, hydraulic hybrid transmissions, but also other continuous variable transmission could be tested. So what we see, we have a hydraulic unit which simulates the engine, and on the other side we have another unit which simulates the vehicle. Both units are 100 kilowatt in power, so we can test on this test rig powertrain transmissions for vehicles with engine sizes up to 180 kilowatt. Now what you see in between is the Toyota Prius original transmission modified, that we took out the electric generator and a motor and took out the battery, replaced the generator and motor by a hydraulic pump and hydraulic motor, and replaced the battery by 2 accumulators, a high pressure accumulator and a low pressure accumulator. So in the high pressure accumulator we will store always the brake energy when the vehicle is braking, and we will reuse this power stored or the energy stored in the accumulator during acceleration. So we use the test rig to test control concepts we are developing for the entire powertrain, involving even engine management.